Hello everyone. I hope you guys had like a good coffee break. So in today's session, we're gonna explain how we integrated a geospatial indexing with S3 and PostgreSQL. So exploring S3 index for large-scale geospatial analysis in PostgreSQL is the main motive of this presentation slides, and we went in depth into how we can analyze and get the data out of it and get all the analysis that has been done. So a quick peek into performance benefits as well, and a real-world application for OpenStreetMap data. So yeah, I myself is Deepak Pradhan. I'm currently studying my master's in computer science in AI as at University of South Dakota. I do have a 6 years of software engineering experience in different mapping part. Here's my colleague.
Hey everyone. Okay, I'm Kshitij. I'm an open source geospatial developer. Currently, I'm studying at Pradhan University at Salzburg for my master's, and I've been in open source since past 9-10 years.
So yeah, going on to that, we have an agenda where we are explaining everything in between those. So first, we're gonna explain understanding S3 and PostgreSQL indexing, where we will be explaining hexagonal indexing, PostgreSQL role, and then we will be go on to S3 and OSM in PostgreSQL, how we can integrate it and experience with Planet data on OpenStreetMap. And also we have a benchmark that has been done, an analysis based on a couple of days of analysis. So we have a data of USA and Nepal building queries that we did with S3 and GEST. So we further go on down with raster analysis with S3, where we have integrating S3 of our raster data cells. And then we will have a quick Q&A. So yeah, quick poll is like, have we had like experience with PostgreSQL? Sorry.
Raise your hands if you have.
Yeah. So, and have we had like used spatial indexing? Anyone? That's great. Yeah. And have you like worked on a huge set of data set, like huge 100 of GB of data? That's even great. Yeah. Explored S3 indexing by anyone? Oh, that's great. And yeah, so I mean, all of these things, if you have done, that's great. Even if you have not done, it's still great, because you're going to know and you're going to get the new keywords that you'll learn today. So hopefully you'll get used to the words. And how many OSM building you think exist across the US? Any idea?
Figure.
Yeah. Any?
How many? 300 million. Okay. 800 million. Okay.
Okay.
Any more? 500 million. Okay.
So we'll see the results. So yeah, it's approximately 71.8 million. So total buildings counted. And this query that we did took 7 minutes on my device with S3 index. Is it 7, right? Oh.
Is it 71 though? You can count it.
Yeah. So, and in the gist, it almost took about 2 hours and 43 minutes. So we have a, yeah. So what is S3 indexing? So S3 is a geospatial indexing system that partitions the world into hexagonal cells. So as you can imagine a beehive, where is it like all those beehive is somewhat like into hexagonal segment. So yeah, based on that, S3 is open source under the Apache 2 license, and the S3 core library is written in C. So bindings for many other languages are available too. So as you can see on the triangle, we have a lot of gap and a lot of distance to calculate for the triangle. And for the square as well, we have a lot of distance to cover. So on the hexagon, the distance is almost equal for everyone. So it's more calculation-wise, it's more efficient. So that's why we went to the approach of hexagons. So number one is hierarchical hexagonal grid, as you can see. So it is the Uber's global discrete geospatial indexing system, and modeling flow between cells. So easier to find the neighbors, as you can see on the pictures, and you can easily jump from one cell to another with equidistant neighbors, and multi-resolution support, where S3 is a hierarchical index. So yeah, and efficient spatial joins across different data set. So now, rest of the part is told by Kshitij.
All right. You can hear me well, right? Yes. Okay. Thank you. So basically, Postgres already provides quite a good geospatial indexing system. I'm not mentioning all of them here, but those are the 3 indexes that we have used for this slide, so that when we did an experiment, basically what we did is we're using gist. We are also using B-tree so that we can index the S3 cell IDs into the Postgres, so it should be easier to find. And we are using S3 extension to get all of those functions in order to calculate the S3 index out of the polygons. Right. So what we did, basically, we loaded OpenStreetMap data, planet data, 5 days ago. It was approx 80 gigabyte, I think, when I loaded in the planet. This is the schema that we chose. The schema is from AutoSM export tool, and then we divided it into line, points, polygons. So for this exercise, we use Postgres 17, which is an interesting observation, which I will tell you later on. And it took 8 hours to build the S3 indexes on line, points, and polygon. It took 11 hours to import, but that is very subjective based on the device that you have. For me, it took 11. If you want more information, I uploaded this into OSM to PostgreSQL wiki as well, so you can see which device I used, or what is the SSD performance for that. And so initially what we did here is we tried to figure out how efficient S3 is. I have been into multiple talks before with the S3 test, but this is way different in Postgres 17. Postgres 17 with newer PostGIS version. So according to my friend Jason on his blog, he said that it took 543 seconds to get the points on the experiment he did for the ST within intersection query, and then 1 second for the S3. But when I tried it on Postgres 17, which is the latest version of it, it was the another case. Postgres 17 is way faster nowadays. Gist is very fast. You can see performance difference between Nepal buildings. I extracted Iran highways, Taiwan buildings, Taiwan road, and then performance is just in not much difference. You can see Gist caught up. But where Gist actually didn't had an issue before was on this query. Not sure I put the right number though, but on this query, if you look into this, the first one, which is through the S3 indexes, it took me 7 minutes to extract those counts of the US buildings. And when I use the gist indexes, okay, it's not there. It took me, there. It took me 2 hours and 43 minutes. So when the data gets bigger and bigger, this is where S3 index shines. So it depends what you want to use it for. Because OpenStreet, US has a lot of buildings, you need to go through a lot of sales. S3 performs brilliantly there. Why? Probably also my friend Barun said, because of the equidistance that S3 has, and also it ties type of the query you are making. Here I am doing polygon to polygon search, right? Based on how many polygons are in this polygon, how many polygons are in this polygon, like that. Okay. And yeah, this is one thing I noticed. This was my initial reaction, but it's not the case. For example, initially, S3 index is cool. I'm going to use it for everything. Performing works better than Gist, but it is a whole new different story in Postgres 17. If you haven't tried it or haven't upgraded your system in 17, I highly recommend if you are doing the special queries. So yeah, this is why I figured out S3 works great when the data is larger. When you are doing a lot of joins between tables, you have different types of the data sets, right? But Gist also caught up for the smaller reasons. If you're only extracting something in Boston, probably Gist is the best way to go. You don't need to build an overhead for S3 index, at least what I think. So there is another section of the S3 where it shines the best is the raster section. For example, you can have Sentinel-2 images. This is on one of the experiment I did. I loaded ISRI land cover in Nepal, and then computed all the S3 indexes, and then computed which category it belongs to. The polygon you see is called compact polygons, which is, if you want to be performant enough, if you are doing some data management, you just want let's say country-wise data. You want to cluster them, right? So compact polygons would work best. There is a library that I developed called cog to S3. You can import it, pass your cloud optimized geodiff, and then pass the resolution. and mean approximate, it will do the create a raster cell into your Postgres. And this is the main key takeaways. Like, I have kind of mixed feeling about S3. It's nice when, as I told you, if you have multiple different sources, you can combine them. It can use as a, you can use it as a universal special index. And based on my experience with Planet data, it works great if I combine it with other sources of the data that is coming as a raster, right? And but PostgreSQL v7 already great. So do you really need this overhead or not? But just keeping in mind, S3 is a one-time insert. Like once you do the one time for all of it, you can keep updating and figure out which S3 cell it's gonna fall in, right? So you can maintain it. You can use it to maintain your huge data set. Currently, I think I have around 3 terabytes of data. And then like once it grows and grows, I can really partition based on the S3 cells that I have. And it is also powerful to go from top S3 cell to bottom S3 cells, children, right? So basically, those are the sources that I used. The schema is from AutoSM expert tool. I used OSM2P GSQL. There is a great S3 runpy, which is the underhood library of the Coq2 S3 library that we developed. And then there is the awesome documentation from s3geo.org. If any of you here who developed this, kudos. Very nice documentation. This is where you can connect with us. And we are both from OSU Nepal. It's a local community developers back in Nepal. And we do a lot of open source stuff. And we'd be very happy to talk with you if you have any questions. And we are open for questions. Thank you for listening. Ciao.